Welcome to this channel, Tech Explained by a Real Expert. I'm a software engineer with nearly 20 years of experience, here to make tech simple and accessible for everyone. From expert insights and honest reviews to practical tutorials and the latest tech news, it's all right here. Subscribe for smart, reliable tech content. Like the videos to show support. Comment to share your thoughts or request future topics. Let's build a strong, informed tech community together.
How does your phone or computer actually send a message across the internet? What happens between clicking a button and your data reaching someone else on the other side of the world? What physical things are involved, like cables, antennas, or chips, to make this possible? Why do we need different layers in the first place? Summary of what this will cover. Why communication in networks is layered like a system of steps. A deep explanation of each of the 7 OSI layers in practical terms. The physical materials and devices involved at each stage. How these layers work together in harmony to move data from one device to another. The layered nature of network communication. To understand networking, think of it as a factory production line. A message, like a product, passes through various specialized stations. Each station has its own job: packaging, labeling, routing, transporting, receiving, and unpacking. These stations are the 7 layers of the OSI model, which help devices communicate over any network, including wired LANs and wireless Wi-Fi. The layers are not random. They exist to break down a complex process into manageable tasks. Each layer only communicates with the layers directly above and below it, creating a flow of responsibility. The application layer, where human intention becomes digital action. This is where your action begins. When you open a web browser, send an email, or join a video call, you're interacting with the application layer. But this layer is not the app itself, rather, it's the layer that lets your software access the network. It understands what kind of data you're trying to send, text, video, file, and connects your app to the protocols that help communicate that data, like HTTP for websites or SMTP for emails. Materials involved? Nothing physical here, yet it's all software. Your keyboard, touchscreen, or voice input is interpreted by apps, which pass data to the deeper layers. The presentation layer: translation and formatting of data. Imagine you write a letter in your language, but the recipient speaks another. The presentation layer acts as a translator. It ensures that the message is encoded in a format that the other device can understand. This layer handles data formatting, encryption, and compression. It can turn a JPEG image into a stream of bytes, or convert text into a universal encoding like UTF-8. It also encrypts sensitive data like passwords, so that even if intercepted, it can't be read. Materials involved? Still within software. Encryption keys may be stored in secure chips, TPM, or secure enclave, but the action happens inside your device's memory and CPU. The session layer, managing conversations between devices. This layer keeps track of your conversation. Just as phone calls have a beginning, middle, and end, network sessions do too. The session layer is responsible for starting, maintaining, and ending a connection between two devices. For example, when you log into a bank website, the session layer ensures your login state stays active across multiple clicks. If interrupted, it can resume or re-establish the connection. Materials involved? Still software-driven, but synchronized by timers and clocks within the device's processor. Timing is everything here. The transport layer, breaking data into packets and ensuring delivery. Now your message is chopped into pieces small enough to travel over the network. These are called packets or segments. The transport layer adds labels to these chunks like part number, whereas the receiver knows how to reassemble them in the correct order. It uses 2 main systems. TCP, for reliable communication like emails or web pages, and UDP, for fast but lossy communication like video calls or games. This layer also keeps track of whether the message got through. If a piece is missing, it asks for it again. Materials involved? The CPU processes packet segmentation. RAM stores the chunks. The NIC, network interface card, queues the packets for sending. The network layer, figuring out where your message should go. This is the layer that assigns IP addresses and decides the best route to your destination. Whether your data has to cross the room, the city, or the planet, the network layer calculates how to get there. Every device in a network has an IP address. Routers use routing tables and algorithms to figure out the best path between devices. Your data may travel through dozens of routers before reaching its target. Materials involved? Routers, firewalls, and gateways, physical devices with routing chips and memory that hold and update path tables. Ethernet or fiber cables carry this information across physical space. The data link layer, communicating locally between devices. The data link layer operates just between two physically connected devices, like your laptop and your router. It assigns MAC addresses, which are permanent hardware IDs given to every device's network card. When data leaves your device, it includes both the destination IP address for long-distance travel and the destination MAC address to hand off data locally to the next device. This layer also checks for basic errors using something called CRC, cyclic redundancy check. Materials involved? NIC, network interface card, inside your device, RJ45 Ethernet cable, if wired Wi-Fi radio module and antenna, if wireless switches which connect multiple devices inside a local network, the physical layer sending the actual bits across wires or air. This is where everything becomes real. Data is now electrical signals, light pulses, or radio waves. If you're using Ethernet, copper wires in an RJ45 cable carry voltage pulses that represent ones and zeros. If you're using fiber optic, lasers or LEDs blink light pulses through glass strands. If you're using Wi-Fi, antennas broadcast radio waves modulated to carry binary information. The physical layer has no idea what the data means. It just transmits it across the physical medium to the next device, which begins the process of interpreting it back up through the layers. Materials involved? RJ45, Ethernet cable, copper, fiber optic cable, glass or plastic, Wi-Fi antennas inside phones, routers, switches, routers, access points, each with ports, power, and chipsets, modems, converting digital signals to analog for internet delivery over ISP lines like DSL or fiber. How it all comes together when you send a message, whether a text or a file. Your device moves the data down through these 7 layers. Each layer adds its own information, prepares it, and passes it to the next. At the bottom, the physical layer turns it into signals and sends it out into the world. The receiving device gets those signals, and the process runs in. Reverse signals become data, addresses get checked, packets get reordered, the conversation is managed, and finally, your friend sees your message appear on their screen. This system is how billions of devices, from smartphones to satellites, communicate every second across the planet. It's not magic. It's 7 layers of very real engineering, working together to move thoughts, media, and meaning through air and wire.
Thanks for watching. I really appreciate you taking the time to check out my video. If you enjoyed it, don't forget to like, comment, and subscribe for more content. Your support means the world to me and helps the channel grow. Stay tuned for more videos, and let me know in the comments what you'd like to see next. See you in the next one.